Very good morning, one and all present. Today, we are going to see about the solved problems on singular transformation method. Okay. Yesterday, we have seen how to formulate the bus admittance matrix. So this is the formula for calculating the bus admittance matrix. That is y bus equal to A into, okay. So y primitive into A transpose. That is A into y primitive into A transpose. This you need to remember. If it is given as impedance Z, then Z is equal to A into Z primitive into A transpose. That's all. So take down this problem. Using singular transformation method, determine Y bus for the network shown in the figure, where the impedance are labeled as shown in the per unit. Okay, so what we need to do is here, we need to okay, find out the impedance matrix, that is Y bus matrix, okay, Y bus matrix, admittance matrix by using the singular transformation method. Okay, where all the impedance are given in that. So this is the bus diagram they have given, and they have mentioned where impedance. Okay, they have given like impedance. So we need to calculate y admittance. That you need to always remember. Okay, so while doing the problem, whether they have given in impedance or admittance, that you need to check. Okay, once again, so that to avoid the confusion. Now, what is the first procedure that we have seen in the yesterday's class? So if you're not able to understand the procedures, you just turn on to my previous videos, and then you can easily know how to do the this one. The first step is to draw the graph. So, okay, from this, we are drawing the graph like this. So how many nodes are there? 3 nodes are there. Okay, the reference node we are taking as 0. Okay, so here what we need to do is we need to formulate the graph. That is, the elements should be replaced by a line. Okay, so if you replace all the elements by the line like this, okay, so you'll get the approximately like this. Okay, approximately like this. So this is the graph for the above network. This is the graph for the above network. Next, you need to mark the elements. So, okay, elements. That is, so I'm starting from A, B, C, A, B, C. Inside, first you need to mark. Okay, and the arrow mark I'm choosing like this. So I'm choosing like it is coming from 1 to 3. Okay, 1 to 3, here 2 to 3, and 3 to 0. Okay, so it is not mandatory like you have to choose the arrow mark like this only. So based on your own arrow mark, but outside arrow mark also, see, outside arrow mark clockwise you need to do. But here we have taken as this arrow mark we have taken as D. Okay, A we have taken as like this coming inside 1 2 3. Here also 2 to 3. We have taken chosen the arrow mark like 2 to 3. We have chosen the arrow mark like this. Okay, and the C we have taken as 0 to 3 to 0, like arrow mark like this. And this, as I said, no, that should be in the clockwise direction. Here, okay, D, A, B, C, D, E, F. Okay, so here the arrow mark we have chosen like this. Here the arrow mark chosen like this. Here the arrow mark chosen like this. Actually, we need to go with the clockwise direction. Okay, so you can also choose like okay here D E F also. So here in this problem it is chosen as D E F and arrow mark like this here coming from A to 1 to, okay, from 1 to 2 and 2 to 3 and here 1 to 0, 1 to 0. So 3 to 0, 3 to 0 and here 1 to 3 and 2 to 3. So here how we chosen the arrow mark now from the ascending order. So okay, so 1 to 3 always this arrow mark flows from 1 to 3, 2 to 3, 1 to 0 like that. Okay, like that we have chosen. Okay, so like that. So first the graph graph, we frame the graph. Okay, next, what is the next procedure? First, we frame the graph. Now, what we need to do is we need to draw the tree. How to draw the tree from the graph? So, no closed loop should be there. That is the rule. Okay, so how to formulate the graph to the tree means the in each and every node, sorry, not node. Yeah, it is a node. So in that, in the branch, in a particular branch, so no closed loop should be there. Okay, if you choose this as a one branch, no closed loop. So here we kept the dotted line, and here you choose this thing now. So no closed loop. So here we kept the dotted line. Okay, and here this three you consider now. Here we kept it no closed loop. Okay, it should that arrow mark and the thing should not frame the closed loop. Okay, so here you see this arrow mark like this arrow mark like this. Okay, so okay, so what I'm we are doing is we are just opening up this. So so no closed loop. Here also no closed loop like this. So here also no closed loop. Okay, so similarly we have chosen the closed loop. You can also choose here also, but the thing is that again here you need to close, and here sometimes it will if you open this, sometimes it will frame. Okay, based on your that is your own wish. Okay, your own wish. It is not mandatory like everywhere. Okay, you need to choose like that. Okay, it is not mandatory like. So here what we did is here we converted graph into three. Graph into three. 0, 1, and 2. This is a reference node 0, 1, 2, and 3. That also we mark. So after that tree, what we have to do? So what is the main formulation of formulating the bus impedance matrix is A into Y primitive into A transpose. A into Y primitive into A transpose. This is the general formulation. So for that, first we need to formulate the incidence matrix A, bus incidence matrix A. So bus incidence matrix A means there are three nodes, 1, 2, 3. How many elements we mark? A, B, C, D, and E, and F. Okay, so F. So based on that, we need to do. Okay, so based on that, we need to do. So first, you take this first element. How to do the first element? So first node, first node, and also with the elements. So first node, if you take first node, which are all going outside. Which are all going outside in the node 1. I think all three are going outside. All three going outside means 1. You need to make it as 1. So, okay. So 1, A, D, and F. We are taking it as 1. All others 0. Similarly, here you take node number 2. Node number 2, which are all going outside. B is going outside. E is going outside. Okay, so and F is coming inside. So going outside, B and E are going outside. So going outside means 1. F is coming inside towards the node 2. So it is -1. Okay, see here we can see -1. F is -1. So B and E going outside. So 1. Others are 0. Next, what is the node number 3? Node number 3. Node number 3, you see how many? So two things, A and B coming inside. C is going outside. Okay, so C is going outside. So coming inside means what you need to do? Coming inside means -1. C is going outside 1. Rest are all 0. So incidence matrix you framed. So similarly, whatever the problem is given, first step you need to frame the graph, and next after the tree means closed loop you should avoid, and you need to formulate the bus incidence matrix. So after that, what is the general formulation? Y primitive is equal to A into A into Y primitive into y bus is equal to A into Y primitive into A transpose. So here we need to transpose this matrix. This is the A matrix we got. Transpose, simply you can transpose this. Rows into column, column into rows. That's all. Rows you need to change into column, column you need to change into rows. That's all. Simply you can change the thing. A transpose that you do. Next, primitive impedance ZB. Okay, so primitive impedance ZB is nothing but first you need to write all the elements here. A, B, C, D, E, F, A, B, C, D, E, F. So what is the primitive A, Y, Z, A? Okay, this all are Z. Okay, Z only. So Z, A is nothing but what is A? Where is A? A here means, yeah, this is the A value. Okay, so J into 0.2. B is what? Yeah, 0.2 again. Next, where is B, C? C here. C here we mark. So here it is again J point 2J. Okay, next, D. Where is D? Yeah, J into 1.0 is the D. Next, what is E? E is nothing but J into 1.25. Next, F. F is nothing but 0.4 J. That's all. So simply we are substituting here. Okay, Z primitive elements. Simply we are substituting AA 0 J into 0.2, BB J into 0.2, CC J into J2. Next DD YDD J 1.0 J. Next EE 1.25 J. FF 0.4 J. Okay, this is the impedance matrix. Next, what is the Y impedance matrix? What we, this thing impedance matrix. So we need to calculate Y bus matrix. So what is Y primitive? Just 1 divided by this values. So zeros, no need to care about zeros because zeros. So Y Z primitive matrix or Y primitive matrix. Go through my previous classes. That's all. Okay. So Y so Z primitive we have calculated. Now how to calculate Y primitive? Just 1 divided by or inverse whatever it may. So 1 divided by J into 0.2, 1 divided by J into 0.2, like that we are doing. Okay, simply we are making it to Y primitive matrix. Next, what is the general formulation? Y bus equal to A into Y primitive into A transpose. So what is A? Already we calculated incidence matrix. What is Y primitive? Y primitive. So this just you substitute here, Y primitive. Next, what is A transpose? A transpose also we calculated here. Next, just substitute it. So now we need to multiply it. Okay, so you can't go with your scientific calculator. Scientific calculator only you can do with 3 cross 3 matrix only. Okay, so you can't do more than that 3 cross 3. So just it is very simple, no? Why? Because all are zeros. So easily you can do. Okay, rows into columns. Matrix multiplication rule is rows into columns. So first this 2 you multiply. Okay, so that you will get the matrix like this. That is minus J5 0 0 1 point J okay, minus J 1.0 J 0 minus 2.5 0 5 J 0 0 minus J into 0.8 J into 2.5 J5 minus 0.5 J 0 0 0. Okay, so into this matrix you got no. Now into this matrix again. Okay, this matrix again. So just to calculate it, you will get to that. Just to multiply it. Okay, that is minus J5 into 1. Okay, so like that plus 0 0 no minus. So this into this. Okay, so again minus 1.0 plus 0, no issues. Again this into this, yeah. Like that you need to multiply. Okay, and if you multiply and simplifying, okay, so you'll get the answer like this. Minus J into 8.5, J into 2.5, J into 5, J into 2.5, minus J into 8.3, J5, 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 minus J into 10.5. You'll get the answer like this. This is the Y bus matrix. Y bus matrix for this particular network as shown in the figure. Network shown in the figure. So again, just we'll rewind once again. So first what we need to do is from the whatever the network given, first we need to formulate the graph.
Excuse me, sir.
And for that graph, we need to add the elements.
Hello, sir.
So elements, what we need to do? Elements, we need to keep the arrow marks like this. So first inside elements, you need to go with the arrow mark, and outside elements, you need to go with the arrow mark. Okay, that is our wish. Okay, so arrow mark is your wish. So whatever the arrow mark you keep, that you can keep. So now after that, what is the next step? You need to formulate the bus incidence matrix. How to formulate the bus incidence matrix? So here 1, 2, 3, here A, B, C, D, E, F. Okay, so here what three nodes is there, elements is there. So whatever going outside, coming inside, that formulation. Next, you need to put a 1 here, and rest are 0. That I already explained. Next, A transpose. Next to Y Z primitive matrix. So that is given in impedance. So first we need to formulate the Z primitive, or otherwise directly you can frame the Y primitive also. No, there is no issues. So whatever the values there, you take it as 1 divided by, like that. Okay. So this step will be avoided. Next, Y bus is equal to A into Y primitive into A transpose. That's all. Multiply it, substitute it, multiply it, you will get the Y bus matrix. Okay. Next, we'll move on to the next problem. Problem. Find Y bus using the singular transformation for the system shown in the figure. So here, luckily, we got whole graph itself. Okay, so like a majority, they will give the whole graph itself. So for avoiding the elements and this directions, and what they will do is in the exam problems, they will give the whole. Then they ask to formulate the singular transformation method. So 5-mark question or 10-mark question, it depends on the question paper. Next, here Y bus match. First, what so graph itself given. So first you need to draw the tree. For drawing the tree, what is the procedure? It should not formulate the closed path. Your nodes so should not formulate the closed path. So what we can do, simply we can remove this first. Okay, so this will not formulate the closed path. Next, for this particular thing, so if you open this will not form. And for this particular thing, if you open this, it will not formulate the closed path. Okay, next again, for this outside is there. Now for this, if you just make it open, then it will not formulate the closed part. For this particular part, if you open this side, it will not formulate the closed part. So now tree formulation is over. Okay, so step by step marks they will give. How you frame the tree, next how incidence matrix, like that step by step. So after that we move on to the incidence matrix A. Okay, incidence matrix A. So how to formulate the incidence matrix? You know, you go to first you just first you write the number 1, 2, 3, 4. Next the elements. How many elements? A, B, C, D, E, F, G, H. Okay, H, I. Up to I it is there. Okay, so first you write wherever the thing is there. First you write. Say for example, so I'm writing like this. Yeah. So first, here 1, 2, 3, and 4. Okay. Next the elements A, B, C, D, E, F, G, H, I. Okay, that's all. So here now you know. Okay, so node number 1. How many elements is there? How many elements going outside? A and C going outside. Okay, and G also going outside. Sorry, not C. A and G going outside. A and G alone going outside. I is coming inside. So -1. So similarly, 2. Node number 2. which are all coming inside G, F, H. Okay, G, F, H coming inside. So -1, which is going outside. B is going outside. 1. Okay, rest are all G. Next, similarly, 3, node number 3, which are all going outside. C, E, F. C, E, F going outside. Yeah, here, not, yeah, sorry. Yeah. So C, E, yeah, C, E, F. C, E, F going outside. Yeah, here 1. Okay, I also going outside. 1. Rest are all 0. That's all. 4. Note number 4. Which are all going outside? Only D going outside. D going outside. And what else? Yeah, H also going outside. 1. Next, E is coming inside. So -1. Rest are all 0. That's all. So now we formulated the yeah. Now we formulated the bus incidence matrix. Yeah. So next what we have to do. So we need to find out the transpose of this. Transpose, you know, how to rows into columns, column into rows. Transpose we did. Next, what we need to do is we need to formulate the Y primitive matrix. Y primitive matrix, how? Y10, Y20, Y30, Y40, Y34, Y32, Y12, Y24, Y13. Or otherwise, you just go with the YAA also. Nothing wrong in that. YAA, YBB, YCC, YDD, YEE, YFF, YGG, YHH, YII. So that particular element. So what is this A? That element, yeah. Sorry, here the values are not given, but actually here it has to be given here. Actually, they missed, I think so. I think they have taken the previous values. Okay, values not given. So simply values not given. So simply what we need to do is we need to take as it is, like Y10, like that only. Y10, Y20, Y30, Y40, Y34, Y23, Y34, how it came? E 3 to 4. So Y34. Okay, like that. Next, Y23, F, yeah, okay. So Y23, yeah. So it is F. F is nothing but Y23, like that. Like that, you have to take Y12, Y24, Y13. Okay, so as it is, you need to keep. So what we are doing is, first we are multiplying Y primitive matrix with A transpose. Y primitive matrix with the A transpose. So simply like that, we are making the transposing matrix like this whatever we calculated, that we are multiplying this with this matrix. So we multiply, you will get the matrix like this. Okay, so you take this as homework, you just do individual row into column like that, you just do it. So you will get the matrix like this. Okay, next, how to formulate the Y bus matrix? A into Y primitive into A transpose. Y primitive into A transpose already we multiplied and some answer we kept. So just we need to multiply with A into that Y primitive. Okay, just if you multiply it, you will get the matrix like this, like Y10 plus Y12 plus Y13. So like this, Y minus Y12, similarly up to Y40 plus Y24 plus Y34. You will get the matrix like this. Next example, take down this problem. Formulate the Y bus by singular transformation for the network shown in the figure. The impedance data is given in the table. Take 1 as reference node. So they have given the take 1 as reference node. So here what it is, 4 buses given. 1, 2, 3, 4. Okay. So similarly, bus code one element 1, 2, 3, 4 is given. Bus code. What is bus code? 1 to 2. 1 to 2 is given. So for that, first thing is 0 point impedance is 0.6, 1 to 3. 1 to 3, the values impedance is given 3 to 4. Next 1 to 2 again. 1 to 2 again. So 1 to 2 again also given. 2 to 4 the impedance values is given. So from this we need to first draw the oriented graph. Okay, oriented graph like this. So the same thing will come here. We need to draw the oriented graph. So first inside you need to mark. Inside you need to mark. So first A, we marked, and this we marked as B. Here we marked as C. Here is E. Here is D. Okay, so as I said, the arrow mark is going from least to higher values. So 1 to 3 is going, 2 to 4 we are taking, 1 to 2 we are going like that. You mark the arrow mark like that. Okay, so from the least to highest like that. So arrow mark you are drawing. So you are giving some notations A, B, C, D, A, B, C, D, E like that. It is not mandatory like you choose the same as A, B, C, D like that. But if you formulate A, B, C, D, E, it is your own wish, user defined. That is user defined. Next, you need to draw the tree. Okay, so what is the rule for tree? Closed loop should not be framed. So if you open this, closed loop will not frame. This you open this, for this loop, the closed loop will not frame. Okay, so like that, first we draw the tree. After that, bus incidence matrix. Bus incidence matrix what? So here, yeah. So this one we taken as reference node. So here we taken as 2, 3, 4. Previously in the previous problem, 0 we taken as reference node. So here in this problem, 1 we taken as reference. So 2, 3, 4, A, B, C, D, E. So yeah, what is 2 here? Which are all going outside, E is going outside. So 1, which is coming inside, A and D coming inside. So -1. So similarly, 3. 3, I think 1 is coming inside, B is coming inside, -1. C is going outside, 1. Rest are all 0. 4. Fourth node. So E is coming inside. Okay. C is also coming inside. Okay, rest are all 0. So here -1, rest are all 0. Incidence matrix we formulated. Next transpose, that you know. Primitive matrix, what is primitive matrix? Primitive matrix. So values are given in impedance. Okay, so values are given in impedance. So what we need to do is, so we need to formulate the, yeah. So Y AA, between AA, what is the thing? It is there 0.60. BB 0.5, okay, CC 0.5J, DD 0.4, okay, EE 0.2J. Okay, so here what we need to do is Y primitive is equal to Z primitive inverse, Z primitive inverse. Just like that, we need to go for the inverse. Okay, so inverse 1 divided by, so 1 divided by, that is the answer here. So Y bus is equal to A into Y primitive into A transpose. A into A transpose. Okay, so here first you need to multiply this two. Okay, Y primitive into that particular A transpose. A transpose, so you need to multiply, you will get the matrix like this. Next, what is the Y bus? Y bus equal to A into Y primitive into A transpose. If you multiply that A with this particular matrix, you will get the Y bus matrix like this. Okay. So yeah, but further simplification, you will get the minus J into 9.1670, 5J, 0, 4J, J2, J5, J2 minus J7. I think you also will get the same answer. So if not, you make the comment, the comment section. Okay, so Y was equal to, this is the matrix for this particular network shown in the figure network, and for these values, this is the Y bus by using the singular transformation method. By using the singular transformation method. So next problem. Form the admittance matrix Y bus of the network shown in the figure. The data for which is given in the table. Select the node 1 as reference. So in the problem itself, they given select the node 1 as reference. And here simply they've given self impedance and mutual impedance. Okay, 1 to 2 impedance is this. 1 to 3, 0.6, 3 to 4, 0.4, 2 to 4, 0.3. Mutual impedance 1 to 2, 0.1. Okay, so first, what is the first step? You need to formulate the graph for this oriented graph for the network, whatever the network shown in the figure. So we need to formulate the oriented graph. Okay, oriented graph like this 1, 2, 3, 4. This first node we are taking the reference. So here what we are doing is we are taking this as A, B, C, and D. Okay, so as I said, how to make the arrow mark means it has to start with lowest node to highest node. So 1 to 2 means arrow mark like this. 1 to 3 arrow mark like this. 3 to 4 arrow mark like this. Okay, here 2 to 4 arrow mark like this. So always you formulate this golden rule. Okay, so if you frame the you just mark the arrow mark from least node to highest node. Okay, so after this we formulated the oriented graph. But what is the mutual impedance here? Mutual impedance given in the problem 1 to 2. Okay, but 1 to 2, I think here they have given the thing wrongly. So this you need to take from as a elements A to B. Okay, A to B. Here I think some mistakes in the problem itself. A to B only they need to give. So A to B or otherwise simply 1 to 2. How to take this 1 to 2 now? We taken the elements like A to B. So instead of 1 to 2, we need to take A to B or whatever the notations you are using. It is not a golden rule. Always formulate with A, B, C, D. You can formulate with P, Q, R, S, T also. It is user defined. Okay, so I can go with A, B, C, D. Okay, somebody can go with P, Q, R, S, T. Somebody can go with U, V, W, X, Y, Z. Like that also. Anything is okay. But here, mutual impedance, how they given to 1 to 2. So 1 to 2, how we have to take is, it is from the first element to second element. So what is the first element we have taken? A. Second element B. So we need to take the mutual impedance between first element and the second element. So it is 0.1. How to frame the tree? Tree means closed loop should not happen. So closed loop should not happen. So if you open this, no closed loop. Okay. So tree is being formulated. Okay. Next, incidence matrix. Okay. First node we have taken as reference. So all others. So you need to start with 2, 3, 4. How many elements we have taken? A, B, C, D. Okay. So 2. So coming inside, D is going outside. A is coming inside means -1, D is coming out, going outside means 1. That's all 0. Similarly, third node. Okay, B is coming inside, C is going outside. B is coming inside means -1, C is going outside means 1. Rest are all 0. Fourth node. Okay, fourth node. C is coming inside, D is coming inside. Okay, 2 are coming inside. So -1, -1. Okay, next, Z primitive matrix. You need to formulate the Z primitive matrix. Okay, so this mutual, sorry, self AA, BB, CC, DD. So what are that elements that you need to take? Okay, so between that A, what is that element? Okay, A means what is that element? Yeah, A is here. What is that element? J into 0.5. That is 1, 2. Why 1, 2? Or Z12, sorry, not Y. It is Z because impedance, no, Z12. Like that, you need to, you already written. Okay, now what is the mutual thing is given? Yeah, mutual impedance is given as 0.1. So 0.1 means it is given between A and B. A and B, that is 1 to 2 only, but element from the element 1 to element 2. So element 1 is A and element. So it is between A and B. A and B is, yeah, this. So here also 0.1. Next B and A also it will come. So here also 0.1. Okay. So this is clear, no? Now, Z primitive, Y primitive is equal to just inverse 1 divided by this values. Okay, so you'll get some something. Okay, so now what we need to do is we need to take because this 4x4 matrix. Okay, so inverse we can't do as a whole. So what we can do is 1 divided by modulus of A into adjoint of E. 1 divided by, so this 2 alone, this 2 cross 2 alone, first we are taking. Okay, so 1 divided by modulus of A, you know, this into this minus this into this. Okay, so you'll get the modulus of A into adjoint of A. How to do adjoint? One simple technique I will tell you. Just 2 you interchange. Whatever there, see, for example, 0.5 and 0.6 just interchange. This 2 just to change the sign. That's all. Okay, that is the simple way. In some other books or some other books, they will give like A, B, C, D. So what they will do, just they will they interchange this element to this element they will keep as minus. So that is user how you practiced in your earlier days. So that you take, but a simple technique I will tell you, just interchange this, change the sign of these two elements. That's all. Okay, so then you can get the matrix like this. So similarly, these two elements. Now these two elements over these two elements. How to make the inverse? The same thing. 1 by modulus of A into adjoint A of A. This you take it as a homework. Okay, so if you calculate, you will get a 2 cross 2 matrix like this. Minus J into 2.5. Here 0, minus J into 3.33. Like that it will go. So Y primitive we calculated here. What is Y bus? Y bus is equal to A into Y primitive into A transpose. Okay, so what we need to do, Y primitive into A transpose, we need to multiply, and we need to multiply with this A incidence matrix. Okay, so simplifying, you'll get. Okay, so again, you need to here Y primitive into this is the answer. Again, A into that particular matrix, you'll get the answer like this. Simplifying, you'll get the answer like this. That is 5.4019 J minus and J into 0.3448, J into 3.33, J into 0.3448 minus J into 4.224, J into 2.5, J into 3.33, J into 2.5 minus 5.833. Okay, this is the Y bus matrix we got for the above matrix so shown in the figure. Okay, so this is the matrix for this particular thing, particular problem given in the thing. Okay, given in the exam.